give us this review with the formula, I was kind of like confused on what means what and how could I implement it? How can I use it?
Right. Okay. So a logistics model is so I don't even know how to explain it to you because hold on a second. I'm having a hard time moving this screen around. There we go. I'm moving it, but it's drawing on it because it's not my Apple Pencil is not charged.
Hmm.
Um, yeah, so a logistics model, basically what a logistics model is, if you think about a graph, things that are exponential, like they go like this, right? It goes and it just goes up like forever.
Mm-hmm.
But in the real world, things don't do that because of like populations and stuff like that. Like the amount of people or animals or whatever in a population affect the end behavior of this graph. So what happens is it
Hmm.
kind of levels off.
Plateaus.
It plateaus, and they call that a carrying capacity, I believe.
Mm.
So 500 would be the carrying capacity
Okay.
for
So
the environment.
okay.
And if you look at if you look at the graph of the logistics as t, think about what this is doing right here.
That would be
As t
time.
gets bigger and bigger and bigger, the denominator gets bigger and bigger and bigger.
It would get smaller because the exponent would be a negative. T would be multiplying to a negative exponent,
I'm
wouldn't it?
sorry, correct. It's getting smaller, right? This part of it's getting smaller. Sorry, let me redo this. This part right here would be going to zero, which means the entire denominator is going to one, getting closer to one, which means this whole number is getting closer to 500.
Mm-hmm.
So this plateau right here
Is
is
500.
500. That's the carrying capacity.
Okay.
So when it says how many bald eagles were originally transported, well, that would be where when time was zero. So plug in zero for t into that equation and find out what you get
Mm-hmm.
when you do. And then it's probably not going to be an exact number, so you can round it. I don't know if they want you to round it probably up. I think the
Um,
answer of this is pretty close to a whole number, but it's a little
yeah,
bit.
I got um 5.9 around that.
Yeah,
And there can't really be a point 0.9 of an eagle. So
right. So since this is just kind of that number is rounded as well, and that coefficient in front of the t is round, it's kind of rounded. So you can assume six, I think.
yeah, okay. Probably.
What is the predicted population in 20 years? Well, then you would just plug in 20 for t
Mm-hmm.
and solve it.
Got it. S- So let me do that. Let me put that into my calculator. Okay. 500 over 1 plus 83.33 times e to the power of negative 0.162 times 20. I got 117. Rounded down.
Okay, sounds about right. And then when will the population be 300? So you plug in
That's
300 for
oh
t,
yeah, so we have to kind of reverse and we have to find t.
right? So that one is where you're going to have to use logarithm
Mm-hmm.
to
Nat
get the exponent out.
natural log, right? Or
Whatever, yeah. Natural log. Yeah, natural log would work better, right? Because you have e. Yeah, so plug it in and solve it. You want to try that? See what you get.
mm-hmm. So 500 divided minus 1 divided by 83.33 um natural log of that answer divided by negative 0.162. I got 29.8. 804 years.
Um, does that make sense?
Yeah. Okay. So the numerator's kind of like the max, real like the realistically max of anything of like
Yeah.
of a like phone company brands material or zoo animals, how much they hold. Okay. And everything in the bottom are just constants except T.
Well, they're not really. They're. I don't know about constants. They're the bottom is the variable.
Wow.
It's a variable expression. Yeah, they're coefficients.
Oh,
Like
okay.
one is a constant, but I
One's a
wouldn't call 83. Yeah,
oops,
whoops. I wouldn't
my
call
bad.
83.33 a constant. I would call that like a probably like a coefficient because it's being
Oh,
multiplied by e.
mm-hmm. Okay.
You know what I mean?
Yeah.
Constants stay the same. Yeah, that number stays the same, but you're multiplying it by e raised to the to a power. So
Mm-hmm. Okay.
that makes sense.
Yeah. Okay, yeah, that formula now makes much more sense.
Do you have another one you can put up there?
Yeah. So up there it is. It should be next to it.
All right, you see my screen, okay?
Mhm.
All right, so compound continuously, you know what that formula is?
Yep.
So A amount equals P times E to the RT,
Hmm.
right?
Yeah, you would first the first 3 months, so it'd be a
Mm-hmm.
thousand times e to the power of 0.068
Good.
times three
Times
equals
P, right?
equals 1,200 and
No, hold on.
29.
No,
Oh,
not three. Three. This is in months, or this is in years. So 3 months, that's 3/12.
oh, okay. So you would okay. So compound the time is always years.
Correct.
Okay, so let me change that. Okay, that just need to change that. Times 3/12 gets you much a big difference. 1,017.15. So $1,017.15.
Yeah. So in other words, in 3 months, you made $17. That makes a lot more sense than making whatever you got if you put in 12 or whatever, or three, not 1/4, right?
Yeah,
You would
okay.
have got a huge number for that, but that wouldn't have made sense, right?
Mm-hmm.
Because you're not
Okay.
going to get in 3 months. They're not going to pay you like you know $400,
$200.
whatever, $200, right?
Okay. So always in times. Always in years.
Mm-hmm.
And for the second part was like kind of my main question. Do you add the new 1,000 to the A of the first part to find um how much money Kim will have
Mm-hmm.
after 6 months?
Yeah, so that's a new principle. I'm sorry. Yeah, that's a new principle. So this
Mhm.
entire thing that you got there is now your new principle. So you
Okay.
by that by E. No, that's compounded monthly. Sorry, but that's your new principle. That's your new P in the equation 1 plus R/N to the NT.
Mm,
And again, your N, it says then each place in prison that pays that much. How much does she have in the account on May 1st? So on May 1st, it's only been in there for 1 month. So your T here is 1/12.
112.
Yeah. And
And we're
your number of compoundings, your N is one.
and would it be one or would it be 12 because it's compounded monthly?
I'm so sorry. Yeah, it's 12. So N and T is one. Yeah, this is 12. So 12 times
Oh,
1/12 is just one. So the number of times you've compounded it is one, basically.
okay.
But yeah, your N is 12 and your rate is 0.0525. And that's your P, that whole number you got there, whatever it was, 1,017, whatever, that's
Hmm.
your new principal.
Okay. And I put that in my calculator. The new price or the new money would be $1,021.60. So only gained $4.
Yeah, and that makes sense, right?
Yeah,
So how much money did you make on average each month when it was continually compounded
you would be
at a how
making,
at a higher rate?
yeah,
Would you say it was a 17 was the total? So you made what, $5 a month or something like that?
around that, yeah.
So, and how much did you say you made in that last month?
4.
Yeah. See, that makes sense because that amount was compounded not continuously. It was only compounded monthly. So it wasn't quite your rate, your actual rate was not quite as high.
Hmm.
The amount of money was more though, but the interest rate was smaller
Yeah.
than the other one as well. So I would have expected that to be lower than the other one, which it was.
Okay.
Okay.
Mm. Yeah. Um, yeah. That question I understand now. Instead of adding another 1,000, you just transfer the A from the first part to the new
Yeah.
P. Okay. I got this question. This question is more like a review for the tests, and I just want to like refresh my memory.
Okay.
Um, for this one, it asks to write the expression as a sum and or difference of logarithms
Yeah.
and express powers as factors.
Okay. Yeah. And they're saying that X is between 0 and 7, which it has to be because that's the domain of this,
Hmm.
right? You can't take the square root of a negative number.
Yeah.
I mean, it could have been 7, I suppose. Like it maybe I would could see them saying that, right?
Hmm. Yeah.
Or actually, I could have seen them saying, well, oh, I'm so sorry. I didn't see the ln out here. The reason it's between 0 and 7 is because this whole thing can't be 0.
Yeah. It would be it would be
This can't
infinite.
be negative, and that whole thing can't be 0. Yeah.
Yeah. The range would be infinite. The domain would be um s- domain would be 7 to infinity, or would it be 0?
Well, they're just telling you what the domain is. Actually, they're just telling you.
Oh,
They're telling you that the domain is that. So you don't have to find the domain, but
okay.
they're kind of giving it to you. So, and I'm sure they're just taking care of that it's the correct domain. So the question is, how do you write this as a, what was it you want to do? Expand it?
As an add and a and wait, write the
Some.
expression as a sum and or difference of logs.
Okay. So you remember the log property that when you
Hmm.
have the log of A times B, it's the log of A plus the log of B.
Yeah.
So that's the first thing we do. Then you remember the other expression or the other property that said you can take the exponent down front. So
Make it
that'd
a
be
make it a
make it a
factor.
factor. Yeah. And then you could also do that with the 1/2 here because that's what a square root is,
Hmm.
right? Square root is just 1/2 power. So that would be like this. And now this is where a lot of people make mistakes. They think, oh, this is a subtraction, so I can divide it. But that's
You
not what you have here.
yeah, it's between parentheses. Like they're like one thing already. It's
Yeah,
that's it.
this is just done. This is just your answer.
Yeah.
What people are thinking when they say that is they're thinking of log of A over B is equal to the log of A minus the log of B. That's different than this.
Hmm.
Okay.
Interesting. Yeah. Um, I know it's 9:08. Like basically, my time is up, and but can I ask one more question?
Yeah, sure. Sure.
It just this one. My teacher was kind of putting an example of it in class as a review. I thought I understood it, but I got the wrong answer.
Okay.
So it just made me questioned my like I thought I knew, but apparently I didn't know as much as I thought I did. So I just
Sure.
wanted to
Sure.
review it with you.
So find the inverse. To find the inverse, you take the y's and the x's and change them. So
Yeah.
anytime you see an x, you write it as a y. Anytime you see a y, you write it as an x, and then
Mhm.
solve for your new y. So to solve for my new y, I'm going to multiply this over. I'm going to distribute the x in. Now I'm going to put the two y terms together. So let's put them on the left side. Subtract the y, and I'm going to move the x term to the right side. So that'd be 8 plus 7x. Get what I'm doing?
Mhm. I see how
Okay.
you do it.
And now I'm going to factor out the y, right? And then divide.
Mm,
So that is your inverse function.
okay. Yeah. F negative to the power of -1x.
And the domain of f is anything but where the denominator is equal to 0. So that can't equal 0,
Hmm.
right? So that would be 3x cannot equal 7, which means x cannot equal 7/3. So the domain is everything but 7/3. The domain of f is everything but 7/3.
Hmm.
And you can write that, in interval notation. I'm sure you know how to do that.
Yeah.
And the range would be the range of f using f inverse. They mean look at f inverse, and whatever the domain of f inverse is,
That's the
that
range.
that whatever the domain, right, of f inverse is the range of f. So the domain of f inverse, let's find the domain of f inverse. X cannot equal 2/3,
Hmm.
right?
Yeah.
So the range would be that y cannot equal 2/3.
Hmm.
This is for f. This is for f inverse.
Yeah.
Got it? So that's how you do that problem.